Taiwan Yes Deep Ocean Water Company Limited. Deep Ocean Water Drawing System and Technology. Scientists believe deep ocean, with its immeasurable mysteries and treasures, is the cradle of all life forms on Earth. Bearing the memories of the ocean from 3.8 billion years ago, human cells aspire to the copious energies of the ocean. Deep ocean water has become the 21st century's blue gold. As defined by the Water Resources Agency, only water acquired from 200 meters or more below sea level can be designated as deep ocean water. At this depth, unreachable by sunlight, no occurrence of photosynthesis, unaffected by air and environmental pollution, contains the most natural, clean and pure water. All of these contribute to deep ocean water's unique characteristics of low temperature, stability, maturity, purity, and richness in minerals. Because of its high economic value, deep ocean water has been praised as blue gold. However, due to geographical locations and technology, only Japan, Hawaii, Korea, and eastern Taiwan have the ability to harvest such precious resources. At Hualien Harbor in eastern Taiwan, where our desalination plant stands, the seabed drops to a fault into the deep ocean only 5 kilometers off the coast. That enables us to obtain real deep ocean water from the Pacific Ocean. How can we ensure the water we obtain is 100% deep ocean water without surface seawater seeping in? The answer lies in the most demanding and quality-oriented water drawing system. Every drop we draw is guaranteed to be 100% deep ocean water. By investing hundreds of millions of dollars, we commissioned Japan Maeda Construction Company to proceed with precise GPS technology, locating deep ocean water at 662 meters beneath the surface of the Pacific Ocean. Blue Gold has finally come aboard. Total length of the piping system is 4,940 meters. The deep ocean water drawing system consists of 4 sections: pumping station, coastline piping, shallow sea piping, and deep sea piping. First section, pumping station. We built the pumping station at 13.7 meters underground by ferroconcrete construction, so the siphon principle can be applied to draw deep ocean water by the pressure of deep ocean upwelling. This method is thus both eco-friendly and energy-saving. Second section, coastline piping. Our drawing pipelines are all made of high-density polyethylene, HDPE, by Sekisui Chemical Company of Japan. The inner diameter is 25.8 centimeters and outer diameter 31.5 centimeters. These pipelines are very flexible, retractable, aseismic, corrosion-resistant, chemically stable, and extremely strong to withstand the unpredictable twist, pull, and drag of currents in the marine environment. The sleek pipe wall guarantees a smooth and unhindered process for drawing deep ocean water. To prevent any outside or man-made damage on the exposed pipelines, we used shield tunneling methods to protect coastline piping and employed SS-1000G mold shield machines by Kokudo Industry Company of Japan. This machine consists of a tungsten steel drill and groups of jacking pipes. Its computerized propelling unit automatically adjusts motive power according to pressure feedback from the drill and jacks 122 RC tubes into the tunnel at a length of 296.7 meters to the exit off the sea. A sea levee was also built to stop seawater intrusion and maintain the integrity of the coastline piping. Third section, shallow sea piping. To ensure the highest quality of water possible, we commissioned maritime engineering professionals to conduct detailed research on terrain features of the seabed, depths, geological structures, water quality in the drawing area, tidal currents and waves recorded along the Hualien coast for the past 100 years. Since the record of the highest wave in Hualien was 25 meters high, professionals had determined the pipeline trenching shall go as deep as 50 meters under the sea, so pipelines would not be destroyed by seismic waves. Within the coastline range of 1,500 meters, a fleet of Japanese giant marine construction vessels equipped with the most advanced GPS and OTS systems assisted us to do the pipeline trenching. We trenched the seabed about 2.5 to 3 meters deep and lay in the pipelines. After confirming the pipeline position by GPS, we backfilled the trench with original sand and soil to restore the seabed appearance and stabilize the pipelines. Furthermore, at the intertidal zone shallower than 10 meters under the ocean, our divers confirmed the pipeline positions personally and applied giant sandbags to increase the stability of the pipelines. Instead of using enamel welding like others, we used Freienlin electrofusion to weld the pipes together and inspected them using high-pressure air to eliminate any possible leakages. Every pipeline welding was individually checked and signed by responsible engineers to ensure the best quality of water. Fourth section, Deep Sea Piping. Both environmental conservation and construction quality are equally important to our company. For example, we used multifunctional RC blocks, which are made from concrete, zeolite, and activated charcoal to stabilize deep-sea pipelines so that ocean life forms can survive. These blocks are shaped into hexagons to provide steady locking of pipelines on the seabed. These RC blocks weigh from 0.5 to 2.5 tons and are positioned on pipelines in accordance with the depth, currents, and terrain features of the seabed. Besides this, we applied sonar and ultrasonic depth gauge to check the depth of water intake and surrounding ocean conditions, while transponders were used to confirm plane position. Backed by this state-of-the-art technology and the world's most precious water resource at 662 meters below the Pacific Ocean, we are proud to present 100% deep ocean water so that everyone in the world can benefit from its amazing effect on health. Taiwan Fertilizer Company Limited, the expert of deep ocean water.